So the first form sat an exam this summer where we had a non-calculator paper and a calculator paper. The test was sat by all four sets, and what I've done here, I've hooked out what I consider to be the most important questions to get to grips with moving forward. So they're mostly numeric questions and algebraic questions. So if you can get to grips with most of these, then I think you're in a good place going into second form. So good luck. Question 1. So part A. So when you've got a number of operations going on, you've got to make sure you do them in the right order. And it's not just a question like English of sort of reading left to right. You've got to know what order to do the squaring, the adding, and the timesing. So the acronym we use is BIDMAS. So we've got to work our way through these 6 possibilities in order. So the first thing is brackets. So do we have any brackets? No, we don't. Now the I stands for indices, which means powers. Do we have some powers? Yes, we do. That 3 squared is powers. So the first thing we do is the 3 squared. Now be careful, that does not mean 3 times 2. It means 3 squared, which is 3 times 3, which is 9. So that is the first thing we do. So we've got the 9 is our first part of our workings. Now moving down the list, we don't have any division going on, but we do have a multiplication going on. 4 times 5 is a multiplication. So the second thing we do is 4 times 5, which is of course 20. And then next thing we do is the addition. 9 add the 20 is 29. Part B. 5 to the power of 3, or 5 cubed, means 5 times itself again. So 5 times 5 times 5. So the 3 comes about because the 5 is repeated 3 times. Now 5 times 5 is 25, and 25 times 5 is 125. Totally fine if you've had to do a little side working to work out what 25 times 5 is, but you get 125. Now part C, this sign here means the square root of 49. So what whole number times itself gives you 49? So working your way through the tables, 6 6s are 36, so that's not big enough. 7 7s are 49, so the square root of 49 is 7. Question 2. So Jane writes down the following. So we've got this times this equals this, and given it's a non-calculator question, NC means non-calculator, we've got to try and figure out why, without doing the exact calculation, explain why Jane's answer cannot be correct. So you've got to imagine you're in a situation you don't have a calculator to check, and does this seem reasonable enough? Or not. So what you do, think about 3.4. What is that roughly as a whole number? Well, that's roughly 3. Now what's 5.3 roughly as a whole number? That's 5. So think about what these two approximations together times together gives you. Well, 3 5s are 15. So think about it. We're expecting an answer around 15. So 180 in a bit just sounds way too big. So the chances are they've just got the decimal point in the wrong place, and probably the answer is 18.02. But all we need to say is that that's just way too big. We're expecting an answer around 15, so I don't know, 12, 13, 14, 15, 16, 17, 18, all of those would be fine, but 180 is just way too big. So what you need to say, you do your approximation, 3 5s are 15, and then you just go and say, well, 180.2 is a lot bigger than 15, so Jane's answer can't be correct. Question 3. So another non-calculator question, and this is just testing your ability to multiply a couple of numbers together. Now, at the end of the day, if you have a method that definitely gets you, that's fine. So stick with it as long as it always works. Now, if you don't have a grid method, now it doesn't have to be this grid method, there are other grid methods, but if you don't have a grid method, you've got to realize that you're gambling. You're either going to get full marks for getting the answer right or nothing for getting it wrong. So I would seriously recommend you have a grid method. So this is the grid method we recommend at King's. So it's the Chinese method, the lattice method. So we set it up like this. So we've got our 45, so our 4 and a 5, multiplied by 238, 238, and then what you do, you put in these diagonal lines into your grid. And then you cross multiply. So 8 4s are 32, 8 5s are 40, 3 4s are 12, 3 5s are 15. Now be careful when it's just a single digit. 2 4s are 8, so that's 0, 8, and 2 5s are 10. Now what you then have to do, you then have to add diagonally across. So across here, across here, across here, across here, and so on, carrying when you need to. So this column's just got the naught. 5 add 4 add 2 is 11, 9, 11, so that's 1 carry 1. Then 1 add 1 add 2 add 3 is 7. 8 add 1 is 10, so that's 0 carry the 1, and then a 0 add the carried 1 gives us the 1. So our final answer is the 10710, which is 10,710. So just to clarify that again, you do not have to do it this way, but if you've got a grid method, it gives you an opportunity to show your workings, so you have a chance of picking up some method marks if you don't get the final answer correct. Part B, calculate 1876 divided by 7. So we do this using the bus shelter method. So pop the first number under the bus shelter, the 1876, set up the bus shelter and divide it by 7, so pop the 7 outside the bus shelter. Now when you're doing a division, you're working your way left to right. So 7s into 1 doesn't go, so you're really thinking 7s into 18. Now 7 2s are 14, carry 4, so we carry the 4 there. So now as we move on, we're considering this to be 47. So 7s into 47, well 7 6s are 42, remainder 5, so we carry that remainder here. So now we're considering this one bit here to be 56, and then 7 8s are 56, so we get the 8 here. So 1876 divided by 7 is 268. Question 4, so another non-calculator question. So we're given a fact, and then bearing this fact in mind, we need to try and work out what this answer is. So what you'll see is that sort of the digits involved are the same. So we've got the 526 here, we've got the 526 here, and the 23 here and the 23 here. So at the end of the day, we're timesing this by this, this by this, so we know our final answer is going to have the digits 12098 in that order. It's just a question of where we put the decimal point. So to allow us to sort of help us do this, I think the best thing to do is to treat this as an estimating question. So what is 5.26 roughly? Well, that's roughly 5. What's 23 roughly? Well, that's roughly 20. What are 5 lots of 20? Well, that's 5 2s are 10, add the 0 to give you 100. So we know our answer has roughly got to be 100. So where would you put the decimal point in the 12098 to get an answer roughly around 100? Well, it's not going to go there, is it? Because that would be an answer roughly 12. It's not going to go there, because that would be roughly 1209. It's got to go there after the 0, giving an answer of 120.98, because roughly speaking, that's about 100. Now, part B, again, we're going to use the information that we're given. So this times this equals this. So working backwards, these digits divided by these digits are going to give us these digits. So we know our final answer for part B is going to have 526 in it. So we either have to put a decimal point in there somewhere to make it smaller, or we can add a few noughts to make it bigger. So, bearing that in mind, our final answer is going to have the digits 5 to 6 in order in it. But what are we going to add a decimal point or some zeros? So let's go back and consider estimating what the answer should be to this. Now 12,098 is roughly 10,000. What we're doing here, we're taking it to one significant figure. That means we're just allowing ourselves one opportunity to have a number which is not a zero. So 12,098 is roughly 10,000. 2.3 is obviously roughly 2. So halving 10,000 we get 5,000. So bearing in mind our answer's got to include the digits 5 to 6 and we want an answer roughly being 5,000, what are we going to do? Well, we're not going to put a decimal point in, are we? Because that's just going to give us answers of around 5 or 52 or around 526. We need to make it a bit bigger, so we go and pop a naught on the end to give us an answer of 5260, because obviously that is reasonably close to 5,000. Question 5. So let's read the question carefully. F equals 5 times whatever x is, and then you add on 2 times whatever y is. Now remember what x and y are. They're just numbers that at this point we don't know. So we would just, once we find out what they are, we just pop them in here. Okay. Now we're told that x happens to be 3 and y happens to be -2. So we just pop these into this equation. Now the key bit is appreciating that 5x means 5 times whatever x is. So that's a key learning point from first form. 5x means 5 times x. So 5 times whatever x is 3, so that's 5 times 3, which is 15. Now moving on to the second term, we're going to add on whatever 2y is. Now 2y means 2 times y, so that's 2 times y, which is -2. Now 2 times -2, now be careful, when you've got a positive number times a negative number, you get a negative number. So 2 times -2 is -4. Quite often we sort of look upon this as being like a happy number and a sad number. So a happy number, a positive, times a sad number, a negative, gives you a sad answer, so -4. So we got 15 minus 4, which means 15 take away 4. 15 take away 4 is 11. Question 6, so another non-calculator question. Express 630 as a product of its prime factors. Now what we're doing here, we're breaking 630 down into its primary form. So we're going to break it down into a product. Product means that loads of numbers being times together. So your final answer must include time signs, not commas. And its prime factors are as far down as you go. So the factors are the integers, the whole numbers that it breaks down to, and you keep on breaking it down until you get to prime numbers. So there's loads of way of breaking it down. You do not have to break 630 down into 63 and 10. I've done so because 63 times 10 is 630, but you could have decided to halve it. You could have gone 315 and 2 or whatever. You'll find that when you get to the bottom of this workings, you get the same numbers. So don't worry about if you've gone a different way, but at the end of the day you should get the same answer. So assuming you've gone my way, 630, my thought process has been it's got a naught on the end, it's divisible by 10, so let's go 63 and 10. Now, are either of these at the end of the line? Are either of these prime numbers? Well, they're not, because both of them can be divided by numbers other than 1 in themselves. So I've broken the 63 down into 9 and 7, because 9 sevens is 63, and I've broken the 10 down into 2 and 5, because 2 5s are 10. Now, looking at the 9 and the 7, have we got to the end of the road with either of these? Well, no, we haven't with the 9, because 9's not a prime number, but we have with the 7. 7 is a prime number. The only way you can break 7 down using whole numbers is 1 times 7. So 7 is a prime number. So what we do in our workings, and this is all our workings on the left, we pop a circle around the 7. So our work is done with the 7. Going over to the 10, we've broken that down into the 2 and the 5. Well, our work is done with either of these. Both of these are prime numbers, so we've put circles around them. Okay. Think of this, I quite often describe it to the class as being like a Christmas tree, and when you get to the end of the line, you put a circle around it, there's your Christmas bauble. So the only one we've got to carry on going with is the 9, because clearly we can carry on breaking the 9 down. What two whole numbers times together give us 9? Well, that's 3 times 3. They're both prime, so we put circles around them. So this is our workings here. We've got a 3, a 3, a 7, a 2 and a 5. Now it's a nicety to put them in numerical order. So it's nice if we do this, it just makes it easier for the marker. So we've got the 2, 3, 3, 5, 7. But what you must do is remember to put the times sign in, because it is a product of its prime factors. Whoops, forget that. Okay, excuse me, then I'm not going to redo the video, we're going to carry on. So it's a product of these prime factors, so you must go and put the times signs in the middle. If you did put commas, I'm afraid you would lose a mark and you would only get 2 out of 3. So to conclude, popping them in numerical order is nice, but popping the times sign in the middle is essential. Question 7. Now, if you're going to get to grips with any part of the maths in first form, it would be this question that I want you to get to grips with. This is basic algebra, and if you can sort of understand what's going on with this, I'm happy that you've learnt well in your first form at school. So, part A. We've got, by showing all your workings, solve this. Now, what we're trying to work out is what y is. Y is some unknown number. So what you have to think upon this, you've got to unpack this to end up with y being on its own. So it's y equaling something. And the way to view it is you work your way into the y. So you don't start worrying about the 8 yet. You deal with the minus 7 first of all. So deal with the bits that are further away from your unknown variable, the letter y, and then deal with the 8 later. So so the key opening point is to appreciate you want to undo the minus 7 first of all. So you choose to add 7 to both sides. Now we put the decision in a circle. This is what we've got to do to both sides in order to keep it equal. So in order to undo this minus 7, we're choosing to add 7 to both sides. So on the left hand side, that undoes the minus 7, leaving us just with the 8y here. And then we add 7 to the right hand side. Obviously 57 add 7 is 64. So we're halfway there. We're getting closer to having isolated y. So we now have to isolate, we get rid of, if you like, this 8. Now what does 8y mean? It means 8 times y, or y times 8. So we have to undo this timesing by 8. What is the inverse operation? What is the opposite of timesing by 8? It is dividing by 8. So we're choosing to divide by 8. And again, make it really clear you've got to do this to both sides in order to keep everything equal. Just keep it fair. So when we divide the left hand side by 8, to undo the timesing by 8, we're just left with y. And on the right hand side, 64 divided by 8 is 8, because 8 eighths are 64. Part B. So exactly the same thought process to part A. We are going to have to choose to make decisions to do to both sides to work our way in until the point that we're just left with x on its own. So you think about working your way in gradually. So on the left hand side, sort out the plus 3 before you worry about the division by 5. So you're working your way into the x. So how do we undo a plus 3? We choose to take away 3, and we have to do this to both sides to keep everything fair. So taking away 3 from both sides, on the left hand side that undoes the plussing by 3, just leaving us with the x over 5. And on the right hand side, 7 take away 3 is 4. So at this point we're left with x being divided by 5 equaling 4. How do we undo a dividing by 5? We times both sides by 5. On the left hand side that undoes the division by 5, leaving us with just the x. And on the right hand side 5 fours are 20. So our answer is 20. And I forgot to mention this earlier on. You can always check your answer. Just pop your answer back in and check that it works. So with x being 20, 20 divided by 5 is 4, and 4 add 3 is 7. So I know I've got the right answer. Let's go back to part A. I thought the answer was 8. So 8 eighths is 64. 64 take away 7 is 57. I know I've got the answer right. Now, part C. Now, bearing in mind, thinking of my my kids in my set, I'm not so worried about this part C. Okay, I think for all of those who are in my class, parts A and B are the real key skills. So, at the end of the day, those of you who are having a look over the summer, if you want to let this one go, that's fine. But give it a go, because it's not that bad. So what you've got to think about, you've got to think about the claw here. We're going to do 3 times y and 3 times minus 2, then 5 times 2y and 5 times plus 1. So I didn't have space to actually draw in the claws here, but just think of these claws being in here, going claw, claw, and claw, claw. And then you work your way along. And this is what the expanding is. Expanding, think of expanding as being getting rid of the brackets. So 3 times y is 3y. 3 times minus 2 is minus 6. Remember, a positive times a negative gives you a negative. Now 5 lots of 2y is plus 10y. And obviously 5 ones are 5. So that would give us 1 mark. We've expanded. We've got rid of the brackets. Now, as the second step, we've got to simplify. Now, when you simplify, that's what's called gather-like terms. So the parts of the terms that you've got that are similar, you gather them together. So let's start off with the y's. So we've got 3y here, and we've got a plus 10y here. So these are like the same species, if you like. If you like, these are like the apples. 3 apples, 10 apples is 13 apples. So that's our 13y. And then moving on to our normal numbers. So think of these as like oranges. We've got minus 6, add 5. Or perhaps easier to sort of picture it, 5 take away 6. That gives us the minus 1. Question 8. Now, anything to the power of 2 means squared. It means itself times itself. So think of this as being t cubed times itself. So t cubed times t cubed. Now, t cubed means t times t times t. And t cubed again means t times t times t. Multiply them together, you're going to get t to the power of 6. Now, when we've got it to this workings, this is one of the rules we teach the kids. When you're multiplying, you add the powers. So obviously that's t to the power of 6. And right back to the beginning, as a shortcut, if you're comfortable with it, if you've got a power within the bracket and a power outside the bracket, you multiply these indices together, and obviously 3 2s is 6. So t to the power of 6. Question 9. So there are only blue counters, green counters, red counters and yellow counters in a bag. Now this is the key part, this sentence here. The probability of selecting a red or a yellow counter is the same. So we've got to bear in mind later on we work out these two probabilities here, they've got to be the same. And so George is going to take a random counter from the bag, and we've got to work out the probability George takes a red counter. So where are we? So what do we know? Probabilities always add up to a whole. They always add up to 1. So as a starting point, we know blue plus green plus red plus yellow must equal 1. So if we add up the two that we've got already, 0.5 and 0.2 being 0.7, How much must the other two together add up to? Well, that's going to be 1 take away the 0.7, which is 0.3. So just going over that again, 0.5 add 0.2, add 0.3 spread over these two is going to give us our whole. Now, because we know the probability of selecting a red or a yellow counter is the same, we've got to spread this 0.3 equally over the red and the yellow. So how do we do that? Well, we halve it. Half of 0.3 is 0.15. Question 10. Now, when we're adding or subtracting fractions, you must have a common denominator. You must have the same number on the bottom. All right, so don't even think about trying to do 7 take away 4 or 8 take away 5. You can't do any taking away until the bottom number is the same. So what is this common denominator? Now, the easiest way to find a common denominator is just to times the two numbers together, and 8 5s are 40. So we know that we're going to have something over 40 taking away something over 40, and then we can work it out. So, bearing that in mind, 7 over 8, 7/8, what is that as being something over 40? Well, what do we do to the 8 to turn it into a 40? We multiply it by 5. So if we're going to keep the fraction unchanged overall, it's just an equivalent fraction, we're timesing the denominator, the bottom number, by 5. We've also got to times the top number by 5, and 7 5s are 35. So 7 over 8 is an equivalent fraction to 35 over 40. Now moving on to the 4/5, same idea. We want it to be over 40. How do we turn the 5 into being over 40? We multiply it by 8. So we must, to keep it unchanged, multiply the numerator, the top number, by 8 as well. And 4 8s are 32. So at this point we haven't done any taking away yet. We've just turned the 7 over 8 into being 35 over 40, and the 4 over 5 to being 32 over 40. But now, because we've got the same denominator, we've got the common denominator, we can now just simply take away the top numbers, the numerators. And 35 take away 32 is 3, so it's 3 over 40. Be careful that you don't change the denominator as you take or add. Now the question does say give your answer in its simplest form, but that can't be broken down any further. 3 is a prime number, so that's as simple as it gets. Question 11. Now this needs to be your thought process. Timesing is good news. This is an easy one. This is just when you do top times top and bottom times bottom. It's not like question 10 when you had to go and get the common denominator. When you're adding or subtracting, that's hard work. You've got to get the common denominator. When you are multiplying or dividing, you don't. So this is an easier question. However, the complication with question 11 is that you've got a mixed number. Okay, 2 1/3 is not just a simple fraction like a third. Similarly, 4 2/7 isn't simple. Now don't fall into the trap that you can just do 2 times 4 1/3 times 2/7. You can't. That will not give you the right answer. What you have to do, you have to convert both of these mixed numbers into improper fractions or top-heavy fractions. So you need to know how to do this. So what is 2/3? What is 4 2/7 as top-heavy fractions? Now think about it. We're dealing with the 2 1/3. We're dealing with thirds. So how many thirds make a whole? Well, 3/3 would make a whole. So every whole number we've got 3/3. So because we've got 2 wholes, we've got 6/3 plus the extra third, so that is 7/3. Now that's quite complicated, but just run the video back to see if you can grasp that. Now the quick shortcut way to do this, but it's really nice if you understand why, is you just do 2 times 3 is 6, 6 add 1 is 7. And similarly with the second one, you do 4 7s are 28 and add the 2 to get the 30. So do make sure you practice going from mixed numbers to improper fractions. It's a really important skill. So really, step one, you're just converting these two numbers into improper fractions, and then from then on it's dead easy. Because it's multiplying, you do top times top, 7 times 30 is 210, and bottom times bottom, 3 times 7 is 21. And 210 divided by 21 is exactly 10, so our answer is exactly 10. Now this is an important skill. You're going to have to do this on a non-calculator paper, so do practice these, please. Question 12. Now you'll see there's no NC written next to the questions from now onwards, so if you need to, you're allowed to use a calculator for now on. So this was the first question on the calculator paper, a nice straightforward algebra question, but it's ever so important you get it right. D plus D plus D plus D. We still don't know what D is, but what we do know, we've got 4 of them. So it's 4 lots of D, 4D. Please be really clear in your mind. This is different to D times D times D times D, which would be D to the power of 4. That's the D with that little 4 in the corner. Now part B, you've got to be very careful to just consider the F's separately from the normal numbers. So as a side working, write down that it's 3F take away 2F. Now be ever so careful to attach this minus to the 2. Okay, don't think of it as 3F add 2F. It isn't. It's 3F take away 2F, which is 1F. Now 1F is kind of okay, but in maths you've got to get used to just writing that down as being F. Okay, I'm not sure you'd get the mark in the real GCSE if you wrote 1F. And then the normal numbers, this bit's more straightforward. Plus 4 plus 6 is plus 10. So we get F plus 10. Question 13. Now a prism is a three-dimensional structure that's got a constant cross-section all the way through. So it could be a cylinder, it might have a circle on the end. It could be a rectangular prism, it could have a rectangle there on the end, or so on. But there is a process you have to follow to work out the volume, the space inside a prism. Now what you do, step one, you work out the area of the cross section. So that's the area of the end bit. So I always encourage the pupils to just shade in the end bit, be it a circle or a rectangle or a square or a triangle, and just go the process of how do you work out the area of the end bit. And then secondly, once you've done that, you take that answer and you multiply it by how deep the prism is. So our second step here is going to be, once we know the area of the triangle, we're going to multiply it by 5. So step one, work out the area of a triangle. Now it's ever so important that kids appreciate that a triangle takes up half the space of a rectangle. Just picture the rectangle here. If we went straight up here and straight across, the area of that rectangle will be 7 fours are 28. But this triangle takes up half the space of a rectangle. So it's 7 fours are 28, but then you've got to halve it to get the area of the triangle being 14. So crucial learning point. Area of a triangle is half times base times height. Now once you've got the 14, as I said earlier on, step 2 is to multiply that by the depth of the prism. So 14 times 5 equals 70. That 8 is a red herring. Question 14. Now this is a number of ways to approach this question, and what I've been trying to get across to the children is that you can almost try and do A and B sort of simultaneously, because each bit helps you with the other. So what I've been encouraging pupils to appreciate is that this table represents coordinates. Now we're already given a couple of coordinates. We're given when x is minus 2, y is minus 2, this coordinate here. And we're also given to start with that when x is 2, y is 6. So what I'm encouraging the kids to do is to go and get the marks for part B even before you worry about filling in the table. So go and plot the point -2, -2. Now obviously you've got to appreciate the first coordinate is the x coordinate, so that's sort of along the corridor left or right. Now because it's a minus, that's going to be to the left, and then our second coordinate is sort of up the stairs, or up or down the stairs rather, and because it's a minus it's going to be down the stairs. So this is 2 to the left, 2 down. Just be careful with the scale, that takes us to this point here. So that's the first point I've plotted, and then the second point I've plotted is 2, 6. So that's 2 to the right and 6 up, which is here. Now drawing that straight line filling up the whole of the graph paper, you have already gained the 2 marks for part B, even before you've started filling in the table. Now you've got two strategies for completing the table. You can either work out the values individually, which we'll come back to in a minute, or if you like you can just sort of use your line that you've got already just to read off the values. So when x is -1, here's x being -1, we're going nothing up the stairs, so our y value is 0. Similarly here, when x is 0, we're going 2 up the stairs to this point on the line here, so that's 2. When x is 1, we can see that y is 4, that value here. When x is 3, y is 8, and when x is 4, y is 10. So it's perfectly possible to fill in these values from the straight line graph you've drawn, and you drew the straight line graph from knowing these 2 points. Alternatively, if you like, just treat this as being an instruction that you follow for every value of x. So I'm going to leave this one, that's quite a tricky one. Let's take this one here when x is 1. So when x is 1, we want to work out the y value. So we take our 1, we pop it into the function. So 2 lots of 1 is 2, add another 2, you get 4. Take this one here when x is 3. 2 lots of 3 are 6, and add 2, you get your 8. Take it here when x is 4. 2 lots of 4 are 8, add the 2, you get 10. Now just for completeness, I'm going to do this tricky one. 2 lots of -1 is -2, add on 2 to -2, you get 0. Question 15. Now I said earlier on, I think it might have been question 7 though, I might be wrong, that the basic algebra is ever so important, but really this is fundamental to maths. You've got to have a feel for proportion. So if you know how much 3 calculators cost, you've got to be able to in your mind have a thought process to work out how much 5 cost. And to do this, just always go back to what 1 costs. So if 3 calculators cost £26.85, how much must 1 calculator cost? Well, it's going to be a third of the amount. You're going to divide by 3. 1 calculator is going to cost a third of how much 3 calculators would cost. So set it out like this, £26.85 divided by 3. This is a calculator question, so that's pop it into your calculator, you get £8.95. Now once you've worked out how much 1 calculator costs, it's very easy going forward. So 5 calculators you're going to times by 5, 10 calculators you're going to times by 10, and so on. So we take our £8.95, we times it by 5, and we get £44.75. Question 16. Now another really key real life skill. If you go into a supermarket, you need to be able to have a process of trying to figure out what's the better value. You can't just say, well, that's because that costs less money, it's better value. You've clearly got to take into account the quantities involved. So what we're really trying to encourage the pupils to do is go back to a single unit of quantity. So with this question here, we're trying to encourage the pupils to appreciate, go back to just what 1 gram of these chocolate bars would cost. So if 50 grams cost 69 pence, then to get what 1 gram costs, you're going to divide by 50. 69 pence divided by 50 using your calculator is 1.38p for a single gram. Now moving on to the bigger bar, Now, okay, first of all, you've got to appreciate you convert £1.89 into 189 pennies to get like for like with pennies. But then it's the same thought process. If 140 grams cost this, how much must 1 gram cost? Well, you're going to divide by 140. 189 divided by 140 is 1.35p. Now we're now comparing like with like quantities. 1 gram with 1 gram. Now it'd be totally okay if you want to compare 2 grams to 2 grams, 10 grams to 10 grams. Equally, it's totally okay if you want to sort of scale up the 50 grams to get to 140 grams. That's all fine as long as you end up comparing the same weight with the same weight. But I just think it's easier in a way just to go back to the unit. So 1 gram here. So get 1 gram equaling whatever, 1 gram equaling whatever. Clearly better value is if it's cheaper. You'd be amazed how many kids get that wrong. So we're looking for this one here. That's the smaller amount. So once we've got this comparison where we're comparing like with like, you can then conclude that the 140 gram bar is better value because it's cheaper.